Alright, well we're going to continue with our properties of exponents, but now we're going to look at quotients, which is really just a division of two powers. So a quotient of powers, if we have x to the fifth divided by x to the third, if we expand that out, that would look like x times x times x times x times x divided by x to the third. X times x times x. Now, anything divided by itself simplifies to 1. So x divided by x is 1, x divided by x is 1, and x divided by x is 1. So we have 1 times 1 times 1 times x, and our answer is just going to be 1x squared. We don't need the 1, but x squared. Now, there is a shortcut. You can take x to the fifth divided by x to the third and subtract 5 minus 3, you get 2. Now, but I really want you to consider the fact that there are more factors of x in the numerator than in the denominator. Wherever there are more factors of x, that is where your result, your power is going to end up. Let's see, sorry. The rule is here. If two numbers with the same base are being divided, subtract their exponents. So let's go ahead and do a couple examples. Here's our rule. Now, oops, sorry. We have our rule here. Now, it says that a is not allowed to equal 0 because there's that important fact that we can't divide by 0. So we need to put that restriction there. But as long as your denominator isn't 0, you'll be okay. So let's check this out. We've got same base. We have to make sure we have the same base before we can do anything. So we have the same base, so we're going to keep the same base. And then we're going to take 9 halves and subtract 3 halves from that. So 9 halves minus 3 halves. Now again, we're talking about the same base. We're talking about the same size piece. If I was talking about a pizza, I'm talking about half of that pizza. There are 9 halves and there are 3 halves, and I'm taking 9 halves and subtracting 3 of them. I get 6 halves remaining. So that just equals 3. So I end up with x to the third. Let's try the next one. If we have y to the sixth divided by y squared, I have more factors of y in the numerator than the denominator. 2 of them cancel out, and there are 4 remaining. Or I could say y equals 6 minus 2. Y to the fourth. And over here, this we're just going to do as 3 separate little problems. We have x cubed divided by x, 3 minus 1. 3 minus 1. We have x squared. Now again, there are more factors of x in the numerator, so this stays in the numerator. Y divided by y. Well, that just cancels out and equals 1, just like it did over here. So y divided by y just cancels out. And, oh, I'm sorry. This is y to the 0 power. Now, we haven't actually done that one yet. We'll do that in a little bit. But y to the 0 power is 1. Anything to the 0 power is 1. So this really says x cubed y z to the 7th divided by x. Y to the 0 is really 1. So it's just divided by x. So we still get x squared. Our y and our z aren't going to change, because we're not dividing anything out. So that would be our final answer. And we'll look at this y to the 0 in a minute. Sorry, I missed that. Alright, down here I have a artistic representation of this rule. So this is 2 powers, the same base. We're going to take the numerator's power and subtract the denominator's power. And we get whatever remains. Just take your yellow and red and subtract out the red, you're left with just the yellow. Alright. Power of a quotient. So we've got 3 divided by x to the third power. So now we've got a quotient, but it's a power of the whole quotient. So this 3 is going to apply to both parts of that quotient. We could go like this and write it out longhand. This 3 meaning there are 3 factors of 3 divided by x, 3 divided by x, and 3 divided by x. And that ends up being, if I multiply that all together, 3 times 3 times 3, 3 to the third over x to the third. So again, this, like our multiplication power of a product, the 3 distributed, in a sense, to both parts. So 3 to the third, x to the third. 3 to the third, x to the third. So we would end up with 3 times 3 is 9 times 3 is 27 over x to the third. And that would be our final answer. So let's try it down here. Let's look at the rule. When you are taking the power of a quotient, the number and the denominator are raised to a power. So in this case it's a number, but if it were a variable, it would be the variable. Both the numerator and, I said number, huh? The numerator and the denominator are both raised to the power. Alright, so here we go. We've got 2 over x to the fourth. We can distribute that 4 to the numerator and denominator. 2 to the fourth over x to the fourth. And we get 16 over x to the fourth. Right here, we get x to the fifth, y to the fifth. And in this case, I wanted to do this example because I want to make it clear that this exponent of 3 does not apply to that 2 because that 2 is not inside this parenthesis. So our power only applies to whatever's inside these parentheses. So this stays a 2, and this 3 distributes to both of these. So we have 2x cubed divided by y cubed. You might also write it 2 times x cubed divided by y cubed. That would be the same thing. Alright, so let's look at the rule. You probably want to get this written down in your notes. The rule is if I take a over b to the m power, it equals a to the m divided by b to the m. So that m kind of gets distributed. And here's the artistic representation of that.